Very good morning. I am Muthuveerappan, Assistant Professor, Department of EEE, JJ College of Engineering and Technology. Today, I am going to give a lecture about the power system operation and control. In this subject, the need for voltage regulation and frequency regulation and the load forecasting. What is the necessity of load forecasting? Why we need for load forecasting and all. First, an overview of power system. A power system consists of generation, transmission, and a distribution system. A power system is a very large network that consists of huge number of generators, large number of transformers and transmission lines, etc. In that, the major components of power system are the generators, transformers, transmission lines, distribution lines, loads, and compensating devices like shunt compensation, series compensation, and static var compensators. So the power, the ultimate aim of the end consumer is to get the reliable high quality power from the generating station. A power is said to be in good quality condition when the voltages and frequency are kept constant. In order to provide high quality power to the consumer, we have to maintain our voltage and frequency as constant. So first, what are the factors that are affecting the power quality? The quality, some of the factors are listed here. The first one is lightning. Lightning plays a major role in the power quality disturbance. And the second one is the switching surges. Switching surges, when suddenly switching on the huge number of motors and huge loads. At that time, the switching surges, and not only switching on the huge amount of loads, but also switching off the huge amount of loads will impact the quality of power. That is meant by switching surges. When switching on and off the huge amount of loads, that will affect the quality of power. And third one is the load shedding. Load shedding is nothing but sudden switching off of huge amount of loads is nothing but the load shedding, which will indirectly affects the quality of power. When we are switching off a huge amount of loads, it will increases the frequency to a huge value. So the next one is electromagnetic interference. Electromagnetic interference is one of the major factors that affect the power quality. And the next one is the operation of heavy equipments. The operation of heavy equipments will resulting in drawing the huge amount of current from the power system, which will affect the voltage and the frequency to the transmission system and distribution system. Next one is the welding machine operation. The welding machine operation, the irregular operation of the welding process, it will affect the power quality. The voltages and frequency may get disturbed due to the irregular operation of the welding machine. And the mal-operation of equipments. The mal-operation of the equipments may also draw huge amount of current from the power system. It will affect the voltages so that it also affect the frequency of operation to the entire power system. So as the conclusion of this, these are the factors that are affecting the power quality. Due to these factors, the quality of power getting deteriorated. What are the necessity for maintaining the voltage as constant. That is the next slide. In this slide, we have discussed about the need for voltage regulation. The transmission lines and distribution lines needs voltage control. To maintain the voltage constant, that is a very important ultimate aim of the power engineer, to maintain the voltage at the consumer end, because all the electrical equipments are designed to operate at a particular voltage and at a particular frequency. So when deviating from this limit, operation limit, the equipment's life of the equipment will get deteriorated, as well as the quality of the equipment will also getting very poor. So that we need to maintain the voltage constant and the frequency constant, then only we can get the 100% efficiency from that particular equipment. So that the maintenance of voltage is very much essential at both the levels, transmission and distribution levels. If the voltage is falls the below normal voltage, what will happen? It will reduces the performance of the equipment. For example, if the light is operating at very low voltage, below average value, below normal voltage, the illumination of the lamp will be very poor. And at the same time, if the normal voltage is increases beyond the normal voltage, it will affect the life of the lamp. It will overheat the lamp, and it will be reduces the lifetime of the lamp. The motors which are operating at below normal voltage draws huge amount of current. When the voltage level is very low, means then the machineries that are operating, it draws the huge amount of current from the power system. It will also affect the quality voltage to the very low level. If the voltage of the power system it deviates from the nominal value, then the performance of the device should suffers a very lot. So our ultimate aim is to maintain the constant voltage to operate the equipments at 100% efficiency. The next one is by adjusting the excitation of the generator at the sending end below a certain limit, that will result in instability problem. It will create the instability problem, and the excitation is above the certain level, means it will create the overheating of the rotor. So these are the some impacts of over voltage or under voltage. If both the cases are very difficult to handle, over voltage means it will also affect the performance of the machine, under voltage means it will also affect the performance of the machine. So that we need to maintain a constant voltage. It is essential to operate the system more efficient and better performance. So the service voltages are usually specified by a nominal value, and the voltage is maintained plus or minus 5% of the nominal value. So the voltage deviation is within the certain possible limits, that is tolerable limits. The limit may be the plus or minus 5% is the tolerance value. So we have to aim to maintain the voltage constant, or at least plus or minus 5% deviation. So this is the need for the voltage regulation. The next one is the need for frequency regulation. Why we need to regulate the frequency? Similar to the voltage regulation, the frequency regulation is also essential in any power system. If the frequency deviation occurs, then we are connecting any two systems, two generators, or in parallel operation, it will spoil the entire system. So what is the necessary condition for parallel operation of two generators. So the first and foremost thing is the frequency should be constant, and another one is the voltage should also be maintained as constant, and the third one is the phase sequence must be constant, must be same. So these are the major conditions to the parallel operation of two generators in a power system. So the frequency regulation is very much essential to undergo the parallel operation of two generators. And then the second one is most of the AC motors runs at a speed that are directly related to the frequency. N is directly proportional to 120 F by P. The speed and the frequency both are directly proportional. If your frequency goes on increases, then your speed of the AC motor is also increases. Since the speed and the frequency both are directly proportional. And the overall operation of the power system can be much better when controlled if the frequency error is kept within the strict limits. The frequency error is to be maintained within the very negligible value. Then only the overall entire operation of the power system should be successful. In order to get the successful operation of power system, we need to maintain the frequency error is very negligible. Then suppose when two systems are working at different frequencies, we are trying to tie the two systems, means we need some frequency converting stations are required to convert the frequency of both the systems are under equal frequency. Then only we can interconnect or synchronize both the systems at one particular frequency. So the frequency regulation is very much essential to operate the two systems in the parallel operation. So these are the necessity of frequency regulation. So the voltage regulation and frequency regulation both are essential to get the high quality power to the end consumer. So we have discussed what are the factors that are affecting the power quality, and what is the necessity of voltage regulation, and what is the necessity of frequency regulation and all. Next one is load forecasting. It is one of the major topic in the power system operation and control. The load in the power system is seldom constant. It is continuously keep on varying from time to time. We cannot predict the load accurately in a particular time period. However, the load can be estimated in advance. It's known as load forecasting. It is based on the previous experience, the past experience. From the past experience, we have to predict how much amount of power is required for the next day or the next month, so that we can approximately predict the load for the next day or next month or next week, for whatever it is. We have to predict the load in advance. Is known as load forecasting. How we have to perform this load forecasting? This load forecasting can be performed in 4 different ways. The first one is very short term load forecasting. This type of load forecasting has to be done for a time period of few minutes to half an hour. So, for what purpose we are doing very short-term load forecasting? Means it is used for real-time control, real-time security evaluation. For this purpose, we are performing the very short-term load forecasting. This type of load forecasting is useful for generation and distribution levels. This is useful for the economic generation of scheduling and load forecasting, load dispatching. The next one is short-term load forecasting. Short-term load forecasting is nothing but it is done for the period for half an hour to few hours. So this type of short-term load forecasting is useful for the generation and distribution level. It is useful for allocation of spinning reserves, performing unit commitment and maintenance scheduling. And the next one is medium-term forecasting. This type of load forecasting can be done for few days to few weeks. This medium-term load forecasting is needed for predicted monsoon acting and hydro availability and allocation of spinning reserves. This medium-term load forecasting is useful for planning or seasonal peak, winter, summer, etc. And the last one is long-term load forecasting. This long-term load forecasting can be done for the few months to few years. This type of load forecasting can be useful to plan the growth of the generation capacity. This long-term forecasting is also required for preparing the maintenance schedule of the generating units, planning future expansion of the system. The need for load forecasting to meet the future demand, long-term forecasting is required to prepare the maintenance schedule of the generating units. For day-to-day operation, short-term load forecasting is required to commit the enough generating capacity for the forecasted demand. Very short-term load forecasting is required for generation and distribution. Medium-term load forecasting is required for monsoon acting and hydro availability and allocating spinning reserves. Thank you.